Logical operators are special operators which work with Boolean values. And when we have Boolean values, we know that these values can either be true, which I will shorthand as capital T, or false, which I will shorthand as capital F. And so let's imagine that we have two variables, A and B, and we can say let A be a Boolean variable, and we can do the same with B. And all initialize on the same line. All right, so let's say let A be true. And let's do the same with B. Let B be a Boolean variable. So we can only hold true or false values, and we'll also initialize it as true. So now we can use a logical operator. There are three that we have available to us, and, or, and not. Let's start with thinking about and. So the AND operator is the double ampersand. And the way that we use the AND operator is you must have a Boolean value on the left-hand side and the right-hand side. So let's imagine we have A and B. So we would read this as A and B. The AND operator will resolve to true when both A and B, or both sides of this operator, are true values. So in this case, with true and true, if we were imagining true and true, we are going to evaluate this to a true value. If we had actually assigned false to B, and we're looking at A and B, we would see true and false, and this would evaluate to a false value. Because the AND operator will only ever return true when both sides of this expression are true, when both sides of this operator are true. We like to use what we call truth tables. And a truth table we can think of kind of like a multiplication table. So let's imagine we've got our values for A on the left-hand side and our values for B on the right-hand side. The only way that we can get a true value out of AND is when both sides of this are true. Every other combination is going to lead to false. So this is the AND truth table. And what this is saying is if A is true and B is true, then the result of A and B will be true. But if either of those values are false, the result will be false. One of the common mistakes that folks make when thinking about the AND operator is thinking about it as if it's the same as equals. So what happens when we have both A and B assigned an initial value of false? And we ask ourselves A and B. What does this evaluate to? Well, this is false and false. False and false is always going to evaluate to false, right? And this is different from is false equal to false. This is where there's confusion. So false is equal to false will be true. False and false will always be false. The only way to get a true value using the AND operator is when both sides are true. Both parts of this Boolean expression must be true. So now let's talk about the OR operator. OR works a little bit differently than and it's pretty intuitive when you get down to thinking about this in terms of how we talk in everyday life. If I'm hungry or there's something that looks delicious on the table, I'm going to eat this food. And so let's think about OR. OR is an operator that uses two vertical bars. So we might make a Boolean expression like A or B. And in this case, since we already have false assigned to both A and B, let's imagine false or false. False or false is also going to evaluate to false. The way that you get a true value out of ORing two Boolean values is when either or both sides are true. All right? Either or both. So let's try assigning true to A. So if A is true, then we'll have an expression that is evaluated as true or false, and this will be true. If instead we had B is true, and I'll leave A as true as well, true or true, this is also going to be true. This isn't an exclusive OR, it's not one or the other, it's either or both. And so the other permutation that we can imagine here is false for A. So false or true. And because one side is true, or the other, or both, this will also be true. So if we want to imagine what is the truth table for the OR operator, we will draw our little truth table, and I would encourage memorizing this if this doesn't come naturally. And we have, we will use true and false to represent B along the top, so these will be B's values, and A's values will be along the left-hand side, true or false. So with the OR operator, when you have both sides as true, you get a truth value out of it. When either side is true, when A or B is true, you also get true, but if both are false, you are going to get false. So this is the OR operator. There's one more operator to talk about, and it's the simplest of the three. It is the NOT operator. The NOT operator will take any Boolean expression and flip its value. So if we have A and we choose not A was, if we assume that A is currently false, not false is true. So this flips the value of an expression. So we can also imagine that, let's say, A is not false, but A is true. The same works the opposite direction. So not A is going to be not true, and as you can imagine, that is false. So the not operator is not a truth table that has two dimensions to it. It only has one dimension to it, and if you give it a true value, it's going to give you false back. If you give it a false value, it's going to give you true back. So the not operator flips the truthiness or the falsiness of a Boolean value. The three operators that we are concerned with when we're talking about logical operators that allow us to form compound Boolean expressions are AND, OR, and NOT.